At the core of technological innovation, where quantum physics defies the limits of the conventional, topological superconductors, a completely new state of matter that transcends the traditional classifications of solid, liquid, or gas, are revolutionizing our future. Microsoft, with its Majorana 1 processor, has managed to manipulate Majorana fermions to create error-resistant topological qubits. Meanwhile, the industrial evolution of electric batteries is advancing as automotive giants such as Toyota, Hyundai, and Daimler collaborate with quantum computing companies to simulate materials at the molecular level and develop more efficient and economical batteries. This technological symbiosis emerges in a global scenario where geopolitical and commercial tensions among world powers are dramatically reshaping supply chains and business models. Don't forget to subscribe and activate the notification bell to receive updates. Let's begin with Microsoft's innovation. For this, let's define what is Majorana 1. Majorana 1 is the world's first quantum chip powered by a topological core architecture developed by Microsoft. This processor represents a disruptive advance in quantum computing. It is based on the physics of exotic particles, known as Majorana fermions, which are at the heart of its operation and give it unique properties of stability and scalability. Let's explore part of its structure. Microsoft has created the world's first topoconductor, or topological superconductor, a new category of material that can generate a topological state of matter fundamentally different from conventional states, solid, liquid, or gas. A hybrid stack of materials. The basic structure combines indium arsenide with aluminum under superconductivity induced by extremely low temperatures. Precise atomic scale fabrication. The construction of the chip requires controlled deposition, literally atom by atom, where the materials must align perfectly. Any defect in atomic alignment would compromise the qubit's function. An H-shaped architecture. Topological qubits are formed by aluminum nanowires arranged in an H shape. Each structure houses 4 controllable Majorana fermions that constitute a qubit. These structures can be interconnected and distributed across the chip in a mosaic pattern. Let's examine some of its operating principles. Majorana fermions. These exotic particles, theoretically predicted by physicist Ettore Majorana in 1937, did not naturally exist until now. Microsoft has managed to induce them through the precise combination of magnetic fields, superconductors, and specific materials. The topological state. It leverages an entirely new quantum state of matter, in which properties do not depend on local details, but on global topological characteristics, conferring greater robustness against environmental disturbances. Digital control versus analog. Unlike traditional quantum systems that require finely tuned and constant analog calibration, Majorana's qubits can be controlled digitally through voltage pulses, similar to flipping a switch, drastically simplifying scalability. Let's now examine some of its technological potential. The topological architecture provides a clear path toward integrating 1 million qubits on a single manageable chip that fits in the palm of your hand. The current chip contains 8 topological qubits in an architecture specifically designed to scale up to 1 million, a threshold considered necessary for transformative industrial applications. The system allows digital control of qubits, radically redefining and simplifying how quantum computing works, and facilitating the execution of the trillions of operations needed for commercial applications. Now let's integrate quantum computing into the design of batteries for electric vehicles. Quantum computing can accelerate battery development by simulating materials at the molecular level, potentially leading to batteries that are longer lasting, more efficient, and cheaper. Toyota has worked with Kunisys, a Japanese company specializing in quantum computing software, to discover new battery materials. They use simulations based on density functional theory to model electronic structures, aiming to reduce errors and increase analysis speed. This is expected to lead to the development of batteries that are more energy-dense, robust, and safe. Hyundai is developing new algorithms to study lithium compounds and their chemical reactions. The goal is to create the most advanced battery chemistry model to date using quantum computing. This could improve charge/discharge cycles, durability, and safety of lithium batteries for its upcoming electric vehicles, aligning with its goal of selling 560,000 vehicles by 2025. Daimler, the parent company of Mercedes-Benz, has collaborated with IBM to simulate lithium-sulfur battery molecules using quantum computing, modeling the dipolar moment of molecules, such as lithium hydride, hydrogen sulfide, and lithium sulfide using a quantum computer. Now let's view both themes from a business perspective, with some key data for decision-making. Electric vehicle sales increased by 25% in 2024, reaching 17 million units sold. The average price of battery packs fell below $100 per kilowatt-hour, a crucial threshold for competitiveness. The price drop is mainly due to two factors: a reduction in the cost of some minerals, for example lithium, which has dropped 85% since 2022, and the expansion of global manufacturing capacity, reaching 3 terawatt-hours in 2024, with the potential to triple in 5 years. China dominates the market, producing over 75% of global batteries, with prices 30% lower than in Europe and 20% lower than in North America. Chinese manufacturers have prioritized lithium iron phosphate batteries, which are approximately 30% cheaper than nickel cobalt manganese oxide batteries. In the United States, battery manufacturing capacity has doubled since 2022 following the implementation of tax credits for producers, reaching over 200 gigawatt-hours in 2024, with nearly 700 gigawatt-hours additional capacity under construction. Around 40% of the existing capacity is operated or developed by established battery manufacturers in close collaboration with automakers. However, domestic development of battery component manufacturing has been slow, so most anode and cathode demand is still met by imports. Emerging as potential production hubs for batteries and their components, Southeast Asia has attracted significant Chinese investments, which could accelerate technology transfer and innovation. In Indonesia, which houses half of the world's extracted nickel, the first plants manufacturing batteries for electric vehicles and graphite anodes began production in 2024. Morocco possesses the largest reserves of phosphate, an essential mineral for LFP batteries, along with an established automotive industry and free trade agreements with the European Union and the United States, factors that contributed to over $15 billion in announced investments in battery and component manufacturing in 2022. For companies in Latin America, operating in an ever-changing environment, external factors such as trade tensions, geopolitical conflicts, and protectionist policies can have a profound impact on their operations, capital, and development. It is essential that every business in Latin America understands that global events can directly or indirectly benefit or harm them. Let's analyze some risks and opportunities. The growing trade rivalry between China and the United States forces many countries to redefine their economic and political relationships. This polarization can force governments and companies to strategically align, limiting commercial flexibility and increasing investment uncertainty. Conflicts in the Middle East, such as U.S. involvement with the Houthis in Yemen, affect maritime flow on strategic routes, for example the Red Sea, forcing logistical routes to be altered, going around Africa, and increasing transportation times and costs for exports and imports. Statements by President Trump, aimed at forcing production to return to the United States, may result in a relocation of investments. This could not only reduce activity and lead to job losses in Latin American countries, but also disrupt established supply chains, as has begun to be seen in the automotive sector. Chinese companies, with highly competitive cost structures, can offer products at significantly lower prices, which represents a challenge for local businesses that must invest in innovation, efficiency, and quality to compete in an increasingly demanding global market. Given the above, it is crucial that companies and businesses in Latin America rapidly increase their competitiveness. To achieve this, it is vital to raise quality standards in their products or services, perfect customer service, implement efficient procedures, and strengthen their personnel skills through soft skills training. Additionally, adopting business intelligence services that provide concise geopolitical information, help identify potential risks, and detect commercial opportunities in their country or abroad will ensure decision-making is based on solid data rather than unfounded assumptions, opening up a wide array of opportunities in both the local and regional markets or in promising markets such as Canada and Europe. If you're looking to boost the competitiveness of your business or company, I invite you to explore Carlos Bastida's portfolio of business intelligence services, where you'll find effective strategies to face today's challenges and seize new opportunities. Links are available in the video description, and don't forget to subscribe and activate the notification bell to receive updates.